Yo, what's up, everyone? Welcome back. Episode, I think 65, 64 maybe. I think 65. Sorry again that I messed up yesterday's episode. I was a little bit upset about that because I recorded literally a 3-hour video and I was uploading it to YouTube. And I keep all my videos on one of my hard drives, and I just wiped all of them, and I forgot to realize that I was still uploading the other one. So, yeah, that didn't work. And I couldn't upload the video, so I guess you live and you learn. But, yeah, we're going to get back into another video today. Probably a shorter video today. I am leaving to Chicago today. So I'll be back Thursday, so there won't be a video tomorrow, but I will make a video Thursday night. Probably Thursday afternoon, something like that. But yeah. Let's kind of jump straight into it. Let's check out Pokemon of the day. Oh, I thought we were going to have Pikachu for a second. 65, we got an Alakazam, the final evolution. Let's take a look at the sound, shall we? Interesting sound. Sounds kind of freaky a little bit, but I feel like I'm getting a little bit sick. My throat here is a little bit sore. Tell my girlfriend my throat's a little sore. I don't want to make anyone sick. I don't think I'm sick, but it is a little sore, so it was a little concerning. Well, let's take a look at this Alakazam. Okay, let's go with it. Hang on. There's my Alakazam sound. Okay, that's our Pokemon sound of the day. I was looking at some Rust videos. We're going to open our powerful study program. Take a look at another binary tree problem, and they got so many binary tree problems. We've done about half. Delete node in a BST. I did see that one in our Leetcode 75. Given a root node of BSC and a key, delete the node with the given key in the BSC. Return the root node reference possibly updated to BSC. Okay. I kind of have a feeling about kind of how to do this one. I think so. We're going to do a recursive approach here. We'll do both. We're passing our node. We're going to call it. So DFS, we're going to pass in our root. And here we're going to have, well, if not node, we're going to return. We'll do if node.val is equal to key, then we're going to do we're going to call the DFS function. We're going to pass node.left. We're going to call the DFS function. We're going to pass node.right. So we're going to skip it. And then we're going to call our DFS function here again. So we're going to attach node.left is equal to DFS node.left. Node.right is equal to DFS node.right. Why is this not working? Node.left is equal to DFS node.left, node.right is equal to DFS node.right. Why does it not like this? Man, my throat hurts, dude. Why are we not returning anything? Okay, we're not. We're still not calling anything. No. I guess we don't wanna return these. We want to skip these, so we want to call the function, but here we want to return node.right, I think. No, we're assigning, hang on. Do we return the node? I think maybe we return the node. Yeah, we just return the node. Okay. Okay, what is wrong here? We're returning 5. Because we're not returning these, we need to return DFS left or DFS node.right. No. Okay. Let's go back. Oh, okay. Our output is 3, so we're not actually deleting 3 here. Okay. We're not actually deleting 3. Maybe it's coming outside of this if statement. It's not actually returning. Maybe we do need a return. Something wrong here. Yeah, it's not handling deleting a node correctly. That's what I thought. Maybe we have to somehow track the parent, I think. Man, I'm not feeling good, bro. My God. What? I did this one. No, I didn't do merge two minor trees. Oh. Had to delete found. Okay, if not root of man. Node has no children, right? And the case 2, node has 2 children, right? So the root of val is equal to I don't know, bro. What do these ones use? I mean, oh, my leg, bro. Ow. I'm kind of doing the same thing. I mean, This is an interesting, clean solution. Okay. Let's get rid of this. Alright, so circle if the key is less than root.val, and root.left is equal to solve.delete node. We pass in our root and our key, right? Sorry, yeah, I mean root.left, that's what I meant. And if the key is greater than root.val, then we want to pass in root.right equal to self.delete node root.right with the key. Okay. So, why are we doing else if the? Oh, okay, we don't want to do, but we don't. Yeah, that is true. Left. Okay. Else, if it's equal, then we want to do case 1, no children, right? So, what would we do when there's no children? So if not root.left and not root.right, then we just return, right? Case 2, 1 child. If not root.left and if not root.left or not root.right, we would return the left if root.left, else root.right. Then case 3, we have 2 children. So if root.left and root.right, then we have to find the in order predecessor. So we make root equal to, sorry, no, we make a temp variable. Temp is equal to root. While temp.right. Sorry, while temp. Because we want to look on the left subtree, but then go right to find the highest value. While temp.right, temp.right. I don't know this part here though.
Oh yeah, you're guaranteed for it to be bigger.
While temp.right. Okay. Temp is equal to temp.right. We got the rightmost value. Then what? Root.val is equal to temp.val. Then we pass in our delete BST. Key. I guess return our root, right?
I guess maybe this should be returned on.
What is actually wrong here, bro? Like, Pi 462. I don't think we're assigning this to children order correctly. While temp.right. There we go. Why? I'm still not sure about the case with 3 children. Can you explain this case? Instead of deleting the node directly, we copy the predecessor's value. Okay, I think I understand. This is definitely a little confusing, but then we reach the Okay, I understand. Interesting way to think about this problem. Again, I don't think I would have got it. Well, I know I wouldn't have got it. Um, some route to leave. How did it? Each node has a value 0 or 1. Each route to leave path represents a... Obviously, I think here you'd use DFS. Okay. We're gonna loop through this. Okay, so what I'm kind of thinking here is that we use DFS to do this. So once we reach a leaf node, I'm gonna use an iterative approach to do this. I'm gonna create a res array, and I'm gonna create a cur array, and I'm gonna create a stack. Okay, it's a lot. Anyway, while stack, I'm gonna pass in the root here. We go through the stack, we pop. So we need our node is equal to stack.pop, right? And then we want to do, we want to find a leaf node. How would we do this? If node dot right, stack dot append node dot right. If node dot left, stack dot append node. Node dot left. I don't think this will work actually, because we're gonna append this, then we're gonna append node dot right, node dot left. I'm gonna kind of visualize this. God, I'm so sleepy, bro. Oh my gosh. Oops. We're gonna visualize this, right? So we're gonna append our 1 here, right? Technically, we're gonna append 0 and 1 then after we process this node. So we'll pop this, then we'll process 0. Sorry, we'll process 1 and then 0. 1, because we're going node dot right, which means we'll pop this, right? So then we'll look at this node, and then we'll append, node dot left, node dot right. So, sorry, node dot right, node dot left. So append 1, and then 0, right? And we'll pop this, right? So I guess maybe when we pop it, then we want to add it to our current, right? So we have 1, 0, right? And then we want to append 0, so we realize this is a leaf node, right? So we pop this, we add it, and we realize it's a leaf, so then we can return this. So this is our first one, right? Okay. We return this. But then yeah, but that won't work though. Nah, it's not gonna work. Because then we're gonna return this, right? And then we're gonna reset the code to be nothing, right? Okay. We reset it to nothing. Alright, I can find it to pop in here is which value, bro? Like, I think it's this one, right? Because then we're going to append 1 with no children. And that won't work. Maybe now that I think about it, this is a recursive problem because we might have to recursively generate each of these paths. Is it a recursive problem though? That's the thing. Like, trying to see if this is a recursive problem. Well, okay. Okay, so maybe we want to create a DFS function. We have our node and we have our cur, right? We pass in our DFS function, we have our node and we have our cur. Our base case, well, if node dot left and node dot right, if not node dot left and not node dot right, alright, then we want to res.append cur and we return, right? If no dot left, right, then we want to return, well, cur, we want to append cur dot append no dot left how do we how do we recursively, when is this Mexican restaurant? I need to figure out when it's Mexican. I'm gonna have to eat before I go, right? Eleven to 9. So we got what? About an hour. If no dot left. I'm gonna do cur dot append. Geforce root. Okay. Alright, root dot left. Oh my gosh. No dot left. Okay. If no dot right, we append current node. Geforce no dot left. Okay. Guess we want to. I want to return. Oh, it's not gonna let me. I want to print cur.
Sorry, I want to print out res. That's what I want to print, not cur. What did I just get? 1 0.
Okay, that's what I thought. We need to get rid of this. We need to append the current path each time, right? Okay. If no dot left, we append. Yeah, we keep passing our cur.
Put an else here. Just put this inside the else.
If not, then we just return. Okay. My gosh, this is meant to be right. Jeez, man.
Jeez, man. 1 0 0 1 0 1 1 1 1 0 1 1 1. Okay.
So now we got that. Now I think we can loop through and just
can we convert these to? Is there a simple? Now we do let's do decimal val is equal to plus equal to decimal val. Let me just return that result. Bro, I put it into a join. Oh, that'll work. That. So we need, okay, so I was right. We need to do this. Dot join map. What's the fastest way to do it, bro? What are some? Hey, we solved it, bro.
Okay. Right in this bush. Okay. Alright. Maybe if we did this iteratively, would it be faster? I don't know. Let's take a look here about doing this with the stack. I think what we went wrong earlier was that we need to append the root, obviously, right? And then the current, I think. Maybe we can just get rid of this and just use this. No, I'm gonna keep it. All right. While stack, then we pop. It's kind of similar way of thinking to our other one. We do while stack, and then we pop our node, and our current is equal to stack.pop. Maybe actually we don't need it because we can reference it in here and think about that. So, right, and then we do, well, we append, right? So code.append node.val. Then we check, well, if node.left, and if not, okay, let's check leaf. If not node.left and not node.right, then we just want to res.append code.copy. Otherwise, we want to, if node.left, we want to stack.append node.left and then our cur. If node.right, we want to stack.append node.right and then append our cur. Let's print out res here. It takes 2 arguments. Oh, we need double parentheses. Double parentheses. Let's see what this gives us. Okay, we're messing something up. I think we need a okay. I don't
don't know. This seems right to me. Maybe this is meant to be copy. Yeah. Oh, there we go. Okay. So why does this need to be copy here? Why does this need to be dot copy? I'm curious. Okay. Okay. Alright, so now we just result plus equal to, oh no, we need decimal value is equal to put into an integer, then we do base 2, but then we need to map our what is it, map string I or something? I don't know, convert it to a string, so this converts it to a string. Hold on. And we map and then we increment our result. And then we simply return our res. We get rid of this print statement. What we got? It can all actually look variable result. Oh, we didn't declare it. Let's declare it. Declare our result right there. Spell decimal wrong. Decimal. Okay. Does that make it faster? Probably not, because there's only all the copies here. So probably, yeah, just as slow. Okay. I guess we could technically add the current sum each time. Bitwise left shift operator. Okay, that's enough for some trees today. Let's move on and do something else. Let's take a look at something different. List of advice for sorting. Searching. Let's do some searching problems. These are probably some binary search problems. If we got Coco eating bananas on here, man, no problem, bro. Binary search. And the peak element. I don't know what to do here, bro, to be honest. I don't know. Let's do this one. Guess number higher or lower. We're playing the guess game. The game is as follows. Pick a number between 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. You can call a predefined API int guess in num, which returns 3 possible results. -1, your guess is higher than the number I picked. Your guess is lower than the number I picked. Or your guess is equal to the number I picked. Return the number that I picked. Well, I assume we just probably use binary search here. Yeah. And call the API. Off the top of my head, do I know how to perform binary search? Not really. Do I kind of know how to perform it? Yes. We create a midpoint. And then we move the midpoint from left to right depending on Okay, so obviously to perform this binary search, we create our low, we create our high, which is the we don't have an array, so our n is equal to 10. Do we create the array? I'm thinking we do. I in range and let's create our array. And we do array.append I. Let's print our array. Let's print our array. There's probably a way easier way to do this. 0, 1, 2. Okay, we want to start from. Let's print our array. Oh, we got from 1 to 10. Okay. So then we create our left is equal to 0. And our right is equal to the length of array -1. while I guess while left is greater than right. Right? Is that? Oh. I guess we should probably rename this to low and high. Equal to high. What do we want to do? We want to calculate our midpoint. Now, remember, this is tricky. I'm trying to calculate it. I was a little confused because I thought it was, well, high plus low over 2. But it's something like high plus low over 2 plus low or something stupid. I don't know. Let's search it up. How to calculate midpoint. Binary search. Okay. Mid is equal to low plus high over 2. Okay, so well, high minus low. Low plus high minus low over 2. Okay, then we do, well, got to do a couple if statements here. So if call API, so let's do, well, guess mid. We can do res is equal to guess mid. If res is equal to -1, which means it's higher. -1, which is higher than our if it's higher than our midpoint, then we want to make our low is equal to mid. Okay, else if our res is equal to 1, this is lower, so then we want to make our high is equal to mid. And then we do another else if res is equal to 0, and we found it, and we would just, well, and then we just return our result. Are we guaranteed think we're always guaranteed something, so let's just return our I guess we can just return mid. Right? I mean, then we just keep going, wouldn't we? Okay, we got an infinite loop. Did I do this correctly? Infinite loop. Approach is almost correct. When the guess is high, you need to set. Oh, not just low as you end up with in infinite loop, since mid will keep pointing to the same number. Wait, really? Why would I get stuck in an infinite loop? I'm confused. Okay, well, something's not right again. What is wrong with my code, bro? Why am I still getting stuck in this infinite loop? Oh my gosh, dude. Output null. Why am I getting a null output? It's unnecessary. Okay, yeah, that is technically true. I thought maybe I'm so stupid. Yeah, I mean, you're totally right. Low is equal to 1. Why am I still getting null here, though? Why is this not returning, dude? What am I doing wrong, dude? I mean, I've got the same code as this guy, other than maybe he's checking two separate ifs. Is it the way my if statements are going? I don't know. I guess we can check. Well, let me just return mid, right? Get rid of this. Change this to if. And change this to else. Else res. Otherwise, in an invalid case, we can just return -1. Will this run now? Runtime error expected. Oh shit, whoops. I don't think that else really matters, bro, honestly. Like, I don't think so. Really? Something's wrong here. I've got something messed up here, bro. Res is equal to 1, low is equal to mid plus 1. Got it the wrong way around, I think. I'm confused, bro. What, like, if our guess, we get the midpoint out of 10, right? If it's 6, why would we change our high to mid minus 1 if it's higher? Like, what? Bro, I'm so hungry as well, like. Bro, if the guess is higher than the target, why are we narrowing the search to the left half? Like, what? Like, when you narrow it to the right half, if it's higher than the midpoint, you'd make the low equal to 5, and then you'd rerun the binary search from 5 to 10. Like, hey.
There's 5 returns 1. Target is higher. Okay. Okay, I understand. Okay. Come back to some binary search. Definitely need to do more problems, but I understand how it works. I just like have trouble like implementing it a little bit. I mean, if I have the internet, you can always easily implement binary search, but okay. The place that's opening for lunch is in 20 minutes, and I'm absolutely starving. So we're gonna do one more problem. Hopefully something simple that's pretty quick. Yeah, let's do the string comprehension one. Is this 57% accepts, right? Okay. Given the array of characters, compress it using the following algorithm. Begin with an empty string s for each group of consecutive repeating chars. I'm so confused. You must run an algorithm that uses only constant extra space. Bro. I think I understand. Yeah, we're doing A, and then we're putting a 2 in front of it, B. We're putting 2B, or A2, B2, C3. The groups are AA, BB, CC. This compressed to A2, B2, C3. Okay, so we're just compressing the string. We have to do an O of one space. So to do this in O of one space, how? Sometimes we have to do it in place too, bro. Oh my gosh, dude, this is actually kind of tough to think about. I do this in O of one space. Oh my gosh. We'd have to think of some sort of algorithm that can delete the nodes. Oh, Python. A list of dynamics so we can easily delete the nodes, but how? So what would 1 be? Would we still do? Okay, if it's 1, then we don't need to. Bro, whoever said this problem needed to be beaten in public. Okay. How can we do this in... Maybe we can have some variable pointing to the first value. If it's an I, then we continue with J, right? So how can we do this problem? I don't know. I'm thinking we can do an O of n squared approach. That's the only way I can think about this, is that if we keep a pointer on this value, right? We loop through. So if j is equal to this, then we increment a counter, right? The counter's 2, so we know how many times did we replace that. Then, oh shit, man. I don't know. We replace this value with the counter, right? Okay. I that's what I think. But maybe there's a better solution. I don't know. I'm gonna ask for some hints. Okay, a 2.0 approach. That is what I said. So we count the consecutive characters. Each group count how many times the character repeats. If the count is 1, simply add the character to the result. If the count is greater than 1, append the character followed by the count to the result. In place modification, you can press a string in place using a list to store the result. Then convert it back to a string at the end. Pointer.
consecutive charts. You know, guys, I think I decided I'm going to call it here because I'm really hungry. Maybe we can look at this problem tomorrow. I'm just really hungry, so I want to kind of go eat. And I gotta drive to Chicago, so I need to get grubbed up and need to do laundry and a bunch of stuff to leave at 12, and I only have an hour and 10 minutes to get everything done. So I'm gonna call it here. I appreciate you guys watching. I will see you guys on Thursday for another video. Okay, see you guys later.